Hello class, we are group 8 and this is what our topic contains, but in this video we are only going to cover nonparametric estimation of credibility parameters. So what does nonparametric mean? Nonparametric means that there are no assumptions about the parameters of the distribution of our risks. This represents our risks. And no assumptions are made about the distribution of the risk parameters. The parameters that describe the distribution of losses or values for this risk. We will be covering the Bowman Model, and within the Bowman Model it is assumed that for any risk they are identical and independently distributed amongst the time periods or the indifferent observations, and that each risk within itself, each of the risks from 1 to R are also independently distributed. So here's a visual of what we're referring to as our risks and the time periods. And within the Bowman Model, we say that each risk only has one exposure. So what we can think of is that we're an insurance company. And as an insurance company, we insure all of these drivers, a ton of different drivers. And we want to know more about the risk that these drivers put on the company. So we're going to pull out a sample of our drivers, and we're going to get data from up to n periods. And this data that we pull is what creates this table. So this is driver 1 in month 1, month 2, month n, and these values represent losses, potentially. And we want this data because we don't know anything about these risk parameters. So risk parameters are unknown, and these parameters describe the distribution of losses for this risk. Another thing to note is that the parameter that describes the distribution of these parameters is the capital theta, and our end objective, we would like to know the hypothetical mean of our risk parameters. So this is the Bowman Model. This is kind of what you just saw above, and all we're doing here is we're taking the average of driver 1, risk 1, the average of his losses, and then the variance of his losses. And we're doing it for the R individuals that we sampled from our pool earlier. And note that these are samples, so we're dividing by n-1 for the variance. And these values are important because they will help us in obtaining the variance of hypothetical means and the expected process variance. And those values are important, the EPV and VHM, because they will help us with credibility, and which will lead to us understanding the hypothetical mean of our risk parameters. So the expected value of the process variance, as you can see, it is just an average. We have all these variances, and we take the average of them. This is useful because it tells us the variability to be expected from the observations of the individual risks. And then the variance of hypothetical means. Well, we have the variance of each of the risks minus the variability to be expected from the risks per period. So it's a measure of the difference in means amongst risks. And as you can see, that this is just a variance formula, and it's the variance of each of these average risk, average loss per driver risk, per the total, this is your X bar, the total average loss. So it's the variance amongst each risk or each driver in proportion to your total average loss. So these are our main calculations, our EPV and our VHM. These will help us with credibility. And again, they're pretty simple. It's just averages and variances. We use them to find credibility estimates. So this is the credibility factor, and K is another new symbol, and it represents the proportion of the EPV and the VHM. So these are all estimates because we have a sample pulled from, we have data pulled from a sample, so it's all estimates. So we need to put the little hats above all of them. And again, the Z helps us. It's like a weight in which we assign some of the weight to each of the risks, the average of the risks, and then some of the weight to the overall average of all the loss amounts. So some of the weight goes to each of these guys individually, and then some of the weight goes to just the total right here. Some of it goes to the total average loss. And this will help us find the hypothetical mean, which will help us understand our risk, the risk to the company, help us understand the risk that these potential drivers that we insure put on the company. So just to recap, the Bowman model, taking averages of each risk, and then variances of each risk, and then taking averages of the variances, and then variance of the averages minus the variance per period. Denoted right there and right here.